Hey guys, welcome to this video, and this video we'll understand about the challenges of a machine learning algorithm. What all challenges you feel while creating a machine algorithm, while making a complete model, while testing and training. Like what are the major thing that you should keep in mind. So we look at these challenges, like what are these challenges, how like what are the best ways to tackle them, when in what cases they arrive, those type of things we'll discuss. So first of all, why this is important. So understanding these challenges is important because see what happens when you're starting out on machine learning journey, right? When you're starting to learn this thing, when you're starting to you know build your initial models, you won't face much challenges because the data that is served to you and the problem statement that is served to you would be something which is aimed at understanding the machine learning model rather than debugging it or facing its challenges or solving its challenges, right? So the goal is not to help you debug it, is just to make you comfortable with it initially. So what happens in this case is we build a lot of machine learning models. We think that okay, we have learned a lot, which is actually true, right? You have learned a lot, but what happened in that case is that you fail to recognize the challenges, right? And when you go with those projects which are quite simpler, which are quite basic, you go with those projects in interviews, they'll ask you questions about how would you debug those problems which you have even not encountered, right? And then it becomes a big challenge, right? Because you have not encountered those problems. If I'll tell you okay, what all if you have got less data, what would you have done, right? So those type of challenges are not seen to you. That is why in this video we will cover, we'll summarize some challenges. Okay, these are the major challenges that we face in machine learning while building a machine learning model, and we'll see okay what all things we can do that can tackle them. Not specifically tackle, but we'll see the reasons also, okay, when they arise and when you should be quite aware, right, in what cases they can arrive. Okay, so moving ahead, the first challenge that we have is of your insufficient quantity of data, right? So, and it's one of the biggest problem, right? So let's take a simple example. Let's say you're training a child. Let's forget about machine learning, right? You're training a child to identify apples. Okay, I am training one kid who have not seen apple till now, right? And I'm training them to identify apples. So I'll show them one apple, a complete cherry red apple. I don't know how to draw an apple. I think this is how we draw an apple. Looks more of a heart, but yeah. So I show him a proper cherry red apple, and this is what an apple looks like. Now comes a little apple which is not that dark red. It's a little bit of scarlet red or any other pattern of red color. There are different kinds of apple, right? And to know to make that kid knowledgeable about knowing all the types of apple, they will require to see a lot of data, right? It's a simple example. If you see more data, if you have more data, you will fail, like your model will learn good things. Like large data, having good amount of data is never a bad thing. Okay, so that is like the one biggest problem that we have is insufficient quantity of data. And generally in that case what you have to do is you have to see a trade-off, right? So what will happen is generally you will face a trade-off between quantity of data, right? You'll face a trade-off between quantity of data versus time and complexity of algorithm. Okay, so either you can spend money to get quantity of data, or you can spend a more time and your computation power on complexity of algorithm, right? So that is basically a trade-off, right? And generally what happens is people don't work that much on data, and is instead of that they focus on more complex algorithm, right? So if I'm preparing for a project, and if I'll have a data of let's say 10,000 k, right? So I have 10,000 rows of data, and I'll start building my algorithm with it. If I'm not getting results, my first approach would be to if I'm not getting good results, my first approach would be to run for a complex algorithm, right? Run for a complex algorithm, right, for a longer period of time. Instead of that, if I can focus, if it is possible, if I can explore the possibilities of having more data, that will solve my problem. That will actually help you a lot. So in these kind of trade-off, if possible, always go for quantity of data. Again, having more data is never a bad thing. More data, it's more good, right? And even if cases when it comes to let's image data, right, image classification, in those cases you need millions of data, because then the variables are many more. So if for people who can understand this, I'll make it quite simple as well for even if you don't understand this. Let's say in simple machine learning model you have 10 features. Okay, you have 10 features and then you have one target variable. In an image data you have an image. Now if my image is 60 by 60 pixel, in easier term you can say I have 36,000 features, right? So for image data you have to train 36,000 features, and this is like basic image. Generally it's like a 3D image, so not a 3D image, it will be a 3-layer image, so you'll have 60 by 60 by 60, right? So that will even take it to higher values, but this is like the basic idea. You have these many features when it comes to image data. That is why if you are training an image algorithm, or you are doing image classification, you need millions of images to create something. Okay, so that is why data quantity is quite important, and the bigger challenge nowadays is having insufficient data. The solution to which would be to generate synthetic data. First of all, right, there are many ways that helps you generate synthetic data organically, not organically but like systematically, like with a proper logic behind them, rather than just copying them or distorting their composition, right? So that is one thing, insufficient data. That was first challenge. Second challenge that we have is a non-representative data. Non-representative data is I think is more bigger challenge than insufficient data. Reason being that insufficient data is kind of a challenge that is visible. You can see, okay, that data is not available there. But in case of non-representative data, you generally find out these challenge after you're training the model, or after you have proven wrong, right? So the biggest example of this is in elections data, right? So for example, let's say if in the upcoming elections I'll convey survey, I'll convey a survey, and I'll ask, let's say 10 million people, 10 million people, right? So this will be something like this, if I'm not wrong, right? So if I'll tell 10 million people, basically 1 crore people, right? So if I'll ask 1 crore people about their opinion, right, and then I'll project something out of it. You can take example of opinion poll and exit polls in this, right? So if I'll ask 1 million people and ask their opinion, and then I'll form some observation out of it. So if now there could be possibility, then when the results come, I could be heavily wrong. This thing has been seen several times in many election across the world. I think it was in US, I think in 1930 somewhere, people saw biggest noticed this, like larger scale, where they were expecting a particular party to win, but completely different party won. Why? Because the people that you are asking, these 1 million people, are different, right? In terms of political scenario, there could be like upper class of people, then there will be lower class of people, economical wise, and there could be like very poor class of people who don't pay that much attention to politics as well, right? And then you ask these 1 crore people, and let's say all of them belong to this class of people, right? You ask them their opinion, and like you get these kind of results. Okay, this particular party has a majority share, but is that the whole data? No. First of all, you're creating a sample of a data, then after that, even after that, in that sample your composition is not similar, right? So basically your data is a wrong representation of whatever results we have, right? So you can say that in general, let's take another example again of population only, right? So in general, our composition would have 20% of rich people. I'll just making this from random. I'm not quoting any statistical organization, but just take an example. 20% people are of good economical range, and then we can say 40% are of a middle economic range, and then we can say 40% are of poor economic range, right? Middle, poor, and this is rich. Okay, now if the sample data that I have has all the people from this data in my sample data, this is my complete population data. Okay, so this will be a population data, this is my sample data. In my sample data, my composition of rich, middle, poor should be ideally be 20, 40 and 40 only. Even if I'm taking 100 data points, it should be this. Then only the result that we'll get from this data would be significant, it will hold more value. Okay, so basically if our data that we are using, obviously we cannot take the whole country's data. So if my sample data is something like my rich are 80% in this, they're 10% middle people, 10% poor people, right? And if I'll take something out of this data, any insight out of this data is flawed. If you want to form a general perception, it will be wrong. Why? Because your data is not, your sample is not the right representative of your population, right? That is the second challenge that we face in machine learning. Because see, this is a general idea, right? Once you'll have this sample of data, everything in your model will be every logic in your model, every pattern in your model will be based on this sample, right? So all of your thing that you'll do after this will kind of be polluted with this particular error that you have ignored, right? So this is the second challenge. First challenge was, let's keep track of what we are doing. So first challenge was insufficient data. Second challenge we had was your wrong representative of data. The next thing is a quite common, actually. It's called poor quality of data. Poor quality of data basically means that you have data with a lot of missing values, you have data with a lot of outliers, lot of null values, right? There are a lot of like cleaning, lot of cleaning is required in data. Now the thing is, a cleaning thing is fine, right? A data scientist or a machine learning engineer, anybody who's working on data these days, is expected to work a lot on cleaning, right? That is not something which you can skip. That is not acceptable for you to skip this thing. Okay, I need only clean data, then I'm sorry sir, you are not expected to work in the field of data science or data analytics, anything. But cleaning of a data is one thing. Having a wrong data or quite untidy data that is of no use, useless data, I would say, is the other thing, right? So let's say I have tabular data, and in that tabular data there is one column of, let's say, right, there's one column of salary, right? This is like the economical data. I have people data, their name, their city, their address, right, their gender and their name, age, everything, and I have this salary column, and I have only 30% of the salary data, and that 70% of salary data is missing, right? So in this case you cannot do anything, right? You are bound to ignore this thing. Like ideally when we deal with null values, there are several ways to deal with null values. If I have this 30% of data and I don't have these data, so there are many ways to deal with null values. One idea is that you drop this column. Other idea is that you replace the other data with the mean of this data, or with the mode of this data, or with the median of this data. So there are ways to clean your data, and you are expected to know that. But in some cases your data is that much dirty or incomplete that you have to ignore it completely, or you have to find a new data, and you cannot do anything in that case apart from finding a new data, or modifying your problem statement, or you can do some other thing as well that we'll talk about. So this is the third challenge, where you have a quite unclean and dirty data set. Next challenge is your wrong features or misinterpreted features would be a right word, right? So it would be something, let's say you don't have correct features. You have complete data, you have a good amount of data, but you don't have good features. Okay, so what does that means is that, let's say I am making an algorithm that predicts heart disease, okay, that predicts whether you have a heart disease or not, and it has many biological and body vitals as a data, right? It includes many things there, right, which I use all of them as a feature. Now there could be certain parameter that is not present in this data, or which is not directly present in this data, right? So in those cases we can use to fix our features. There are multiple methods, right? So first of all, what is the challenge is that your features are not correct. You have incorrect features, right? And you're feeding them to your machine algorithm. Now what you can do in those cases, you can do feature selection. Like these all are part of feature engineering. First of all, feature engineering is you are engineering or working around your features. Then inside that you have feature selections, right? And then you have feature creation would be one thing, right? Feature creation. So feature selection basically is that once you have prepared your model, you can see what particular feature is impacting your model more, and then you can focus on those features and ignore the rest of the feature, right? Because in machine learning there is a thing called bias variance trade-off, and that is basically means that as your complexity of a model increases, your variance will increase and your bias will decrease, right? So in easier term, you can say more complex your model becomes, more noise it start getting, it start capturing more noise, right? And you can say randomness it start catching. So it's better to have less features which are not useful, ignore features which are not useful. That is a good thing to know, right? So feature selection help you in doing that. Feature creation or feature engineering in general helps you create new features, right? So for example, if I have it could be application, right? Let's say in my data I have weight and I have height, and I'm using those two parameters separately. Right now I can observe, hey, if I have my weight, I have my height, I can create a BMI, body mass index feature based on these two columns, and then I can use that feature in my data. Now this will do two things. First of all, it will exclude my two features and include their value in only one feature, right? And it might give me good result. Now again, it's all trying, testing, guys, but this will generally create an idea because you have created one new feature which was not there, right? It's like you are giving more options for your machine learning model to learn. Take it like this, right? See, when you're learning a new problem, when you're learning a problem, let's say I'm teaching you something. If I give you one example, you will understand the problem. If I'll give you two example for that same problem, you will understand it more. If I'll give you three example, you will understand even better, right? Same thing goes for machine learning model. All of those features are kind of real life examples that you are giving to your machine learning models, right? So more advantage, more valid examples you give to your model, more new example you give to your model, more good thing it will learn. Again, don't confuse it what I was saying previously, where I was saying you should have less features. You should ignore features which do not impact your machine learning results that much. Basically your features which are not putting that much of a contribution in your machine learning model. There are ways to interpret your model. Some of them I'll discuss: lime, sharp. There are multiple algorithms or library, Python libraries that helps you interpret your model, understand how your model is performing. So you can use them, or you can use just feature selection, which gives you a feature score. Okay, what or how much each particular feature is contributing in your machine learning model. So there are multiple ways to do this, but I hope you got an idea what we are talking about. Having a right features, creating a right features is another challenge in machine learning. Okay, that is our fourth, if I'm not wrong, yeah, fourth thing. Next thing that we have to understand is a quite interesting concept which is called overfitting. See, so overfitting is like this. This is a simple example, guys. Let's say this is my data, and this is my x values, and this is my corresponding y values, and my data is basically y is basically a function of x, right? And it looks something like this. So the points are coming here, 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 and here, and then here. Okay, now these are my data points with different values of x. I have different values of y. Okay, I have different values of y. Now when I start learning this pattern, right, my expected line to learn, let's say I'm doing a linear regression here, my expected line is that, okay, it should be something like this. Okay, it should something like this. Now, and if a problem can happen, and I'll tell you why will that happen, but a problem can happen is that it might go something like this. It might go something like this. There are two patterns that I am trying to learn, guys. This is one pattern, and this is the other pattern. This is pattern number 2, and the red one is basically my pattern number 1. Now what will happen is that there are two patterns, and ideally we opt for second pattern. Now you would be thinking, yeah, but pattern number 2 detects your pattern more easily, right? I can catch all of my models. So the goal of your pattern catching was not to understand what catch all the patterns. It was to generalize a particular pattern, Okay, try to understand the goal of machine learning here, guys. These are my data points, the black points are my data points, and what I want to do here, like my aim is that when a next value of x come, let's say these were all the values of x, and now have x value of x1. For this value of x1, can you give me the most appropriate or more approximate value of y1, right? And this would be that value y1, which I can say, yeah, it will come somewhere like here. Now this is when we follow the red line pattern. What if we follow the green line pattern? See, the green line pattern is coming something like this. There is no track there is no nothing, no pattern that I can, exactly, there's no pattern that I can follow. There is just a design, right? So if I'll come at this particular point, so can you guys suggest me where it will go? Can it go down? Can it go up? Can it go here? Can it go this? Can it go that way? It can have, anything can happen, right? Because the pattern that the design that you have created before this does not give you any information, right? So this is basically overfitting, where you are not actually capturing the pattern, you are just capturing the noise as well. So in our data, guys, in our data you have a deterministic part plus you have a error part, right? Or the noise part, deterministic part and the noise part. So in this data, this is basically my deterministic part, right? And when you will see this part, this is basically my noise part. Individual these efforts are my noise part. So when you are trying to catch your noise part as well, in that case you end up with algorithms which try to catch each of your line data point, and which eventually, you know, end up catching the noise of your data, right? In that case your model overfits. What's the problem of overfitting? That you will have a good amount of error when you will go for test data. When the new data point will come, you will not be able to identify correct value for it. You will get a lot of error. You will have a good good training error, like, I mean, less training error, but the test error would be high. So basically what you are doing, you are trying to memorize the data instead of generalizing it, right? That is the biggest problem that you are making here. So yeah, that is overfitting. Generally overfitting happens when you have less data and you try to implement more complex algorithm in it, right? In that case, is overfitting would happen. If you have less data and you're implementing a very complex algorithm in it, general way to reduce overfitting is to choose for ensemble models, or either get more data or go for ensemble models. Ensemble models basically are bagging and boosting model, which have bunch of algorithms together, put in together, and then they kind of take a majority voting and the sequence voting, and there are multiple ways, but you are using more than one model, so you're capturing patterns in a different way, generalizing it, right? So that helps you cover overfitting. Next thing is underfitting, which is quite an easy thing. Underfitting basically has that you don't have data. If you don't have much data, your model underfit, basically it will not be able to identify the pattern only, right? So let's say in previous example we had a lot of data points. Let's say I just have 3 data points here. So my data point something like this and this. Can you tell me where would what will be the value of my next x value? No, you cannot tell me. It can go here, it can go here, it can go here, it can go here, anywhere it can go, right? So underfitting basically means that you don't have enough data to train your model, and your model is not performing well on your training data only, right? In an upcoming video I'll discuss about training data, test data, validation data, and like what are the difference between them, how should you do sampling and all those things. But this was it for all this video, and do let me know in the comments how did you like this video, was this effectful for you. These are like the fundamental challenges of machine learning that people face, and you have to keep this in mind, and it's quite important to know, right? So thank you, and I'll see you again.